When we talk about gases, there are several different laws or rules that we can use to describe their behavior. The first rule that we're going to talk about is Charles's law. And Charles's law describes the relationship between volume and temperature. And when we have these relationships, we have to say and make some assumptions that the pressure and amount of gas stays constant. So we're simplifying this relationship by saying pressure and the amount of gas stays constant. So let's look at what the relationship is between volume and temperature of a gas. As you watch this simulation from PHET, watch the two variables, volume and temperature. So here's temperature and here's volume. And what's going to happen is that I'm going to increase the temperature of this gas by adding heat. So I'm adding some heat, and you'll notice that the particles speed up because higher temperature means faster particles. The temperature is going up, and what happens to the volume? Well, the volume of the container is increasing. Well, why does this happen? Well, the hotter the particles are, the faster they are moving. The more they bounce off the container, the more they bounce off each other, and they tend to spread out. So they're bouncing off each other a lot, they spread out away from each other. When we cool the particles down, they slow down, they don't bounce as hard off each other, so they're able to stay closer together and their volume decreases. So as temperature goes up, volume goes up, and as temperature goes down, volume goes down. And again, if volume went up, temperature would also go up, or vice versa. If temperature goes up, volume goes up. And if volume goes down, the temperature is going to go down, and vice versa. If temperature goes down, then volume will. This type of relationship, where one variable goes up and the other variable goes up, is called a direct relationship. This just means both variables do the same thing. For example, one goes up, the other must go up. And we can use this relationship to solve problems with gases. So we can ask the question, if I have a gas and I change its temperature or volume, what happens to its temperature and volume under the new conditions? The equation for Charles' law is V1 over T1 equals V2 over T2. The volume under the first set of conditions with its temperature equals the volume under the second set of conditions with its temperature. The volume must be in liters, and the temperature must be in Kelvin. So if you're given a unit that's not liters or Kelvin, you're going to have to convert. Let's look at a sample problem. Let's say that we have a gas that has a volume, V1, of 3 liters, an initial temperature of 30 degrees Celsius. We change, let's say, its temperature. So its new temperature is 50 degrees Celsius, and we need to find what its new volume is. Notice that when I write out this problem, I label my variables right away. So I label V1 equals 3 liters, T1 equals 30 degrees Celsius. That's the volume and temperature of the gas to start. and then the temperature of the gas under the new conditions is 50 degrees Celsius. So what does its volume become? But remember, we have to check units. We have liters, which is fine, but then we have degrees Celsius, so we need to change that to Kelvin. Well, to convert, I add 273. So here I get 303 Kelvin. And here I get, for the T2, I get 323 Kelvin. So let's plug into the formula. V1 is 3, T1 is 303, equals, we don't know V2, I'm going to leave it as a variable, but we know T2, which is 323 Kelvin. We're going to solve for V2, and when we get that, V2 equals 3.20 liters. So when we increase the temperature to 50 degrees Celsius, the volume increases by 0.2 liters. So it goes from 3 liters to 3.2 liters. And that is Charles' law.